So in this session of m squared m cubed or 2, Mrs. M's Math to the Masses in a minute or two, we're still talking about compound events, but we're moving past the simplicity of multiplying two independent events together, and we're now going to be looking at the probability of dependent events when the outcome of one event, the first one, does affect the outcome of the other event, and what's going to change is our second ratio. So we're moving down the page. In our examples here with dependent events, we're still working with those crayons we had. So I'll rewrite that we had 8 that were red, 14 that were purple, 6 that were yellow, and 4 that were green. If you remember, we added those up to find out how many total crayons we were choosing from, and it was 32. So when we start with the probability of drawing out a yellow crayon, then a red, it starts very straightforward. Yellow, we said, were 6. So 6 over 32. But now we are not putting it back in and replacing it. We are having one less crayon to draw from. We're setting it aside, so we only have 31 to choose from. And out of these 31, we still have 8 red. So then we put an 8 here. And we multiply the numerators together and the denominators together, and we get 3 over 62, which becomes 0.05. You can pause and do this in the calculator. So I work through it. That's a 5% chance of drawing a yellow one, leaving it out, and then out of the remaining ones, drawing a red. Let's try the probability of purple then green. Okay, so we remember with purple, there's 14 out of the 32 that are purple. We took one purple out, so now we only have 31 to choose from, and we do know there's still 4 green. So we're going to multiply those two together, and we will get a 7 out of 124 chance that we would be able to do that. That's a 0.06 as a decimal answer, which is about a 6% chance of drawing a purple then a green. How about 2 reds in a row? This is going to be interesting. We know we have an 8 out of 32 chance of getting a red because we started with that. We know for the second draw, we only have 31 to choose from because we're taking out the first one we drew. And whereas we had 8 to choose from the first time, since we took a red out, we now only have 7. When you multiply 8 32nds times 7 31st, we will get a 7 out of 124 chance, which we know from doing a previous problem equals 0.06, or about a 6% chance of getting 2 reds in a row. How about 2 greens? Same type of approach. We know green, there were 4 out of 32 for the first draw. When we drew it and kept it out, we now have a 3 in 31 chance. We multiply those together. We have a 3 out of 248. Let me make that a 2. 3 out of 248 chance of getting 2 greens in a row, which is 0.01 when you change that fraction to decimal, and it's about a 1% chance of achieving that outcome. This is a 2. Okay. Now we have a card being drawn from a standard deck and not replaced. And another is drawn. What is the probability of choosing a heart then a spade? So we have a 13 out of 52 chance of getting a heart because there's 13 cards in one suit. And now we want to be able to choose a spade. We took the heart out, so we only have 51 cards left to choose from, but we're moving suits, so we still have 13 spades in that deck we're choosing from. That will equal 13 out of 204 chance of doing it. which equals 0.06 as a decimal, and about a 6% chance as a percentage. I like all answers all three ways. Okay, one last example of dependent events. Jack had 4 Snicker bars and 8 Mars bars. He randomly chose a piece of candy and ate it, then chose another. What is the probability that both candy bars were Snickers? So he had 4 of those, but he started with 12 total bars because he had the 8 plus the 4. So he wanted to randomly get 2 Snickers. Then, since he ate one, the next time he only has 3 to choose from out of 11. So that gives us 12 over 121, which equals 0.09, which is about a 9% chance. There are your examples of dependent compound events.